again, I recommend that you click on this link over here and watch someone else talk about the problem. It's nice to have a variety of people talking about the same problem, by the way. So looking at this thing, it kind of reminds me of another problem that students are often faced with. Instead of the I, let's say there were two here, two there, two there, two there. Now it reminds me of a Calc 2 question. And the teacher would say, what's X? And then they'd probably go through this demonstration over here. They'd probably just square both sides. And would they get 2 plus, they'd get this, complicated root again. I'm going to say that complicated root is still just X. And then on the other side, when you square that, they get X squared. And that looks pretty simple, by the way. Again, I want to point out what X is. X is this thing over here. Well, if you square both sides, it's an infinite nested root. You're expecting to get the same thing back over and over again. What do you get here? Let's write this down. 0 equals X squared minus X minus 2. And then 0 equals X, 2 and 1. Let's see, you get minus 2 plus 1. And you get two solutions over here. X equals minus 1 or X is equal to 2. So, and you could show it's equal to 2 now, all right? Now, granted, I wouldn't say minus 1, principal root, positive number. So this reminded me of that, all right? Now, what does this depend on? Depends on convergence, all right? And that's where the complex number is a little more difficult for me. It's easy to show the other one converges the two, but the bottom line is this might be more difficult, all right? So you assume it's convergent. Assume this is convergent. What do? You square both sides. And what would you get? You get I plus X equals X squared. Again, when you square that thing, it's a nested root. It just gives it back the same old, all right? And then the question goes is, what do they want you to do? They say X is equal to A plus BI, with the understanding that A and B are real numbers, all right? Then you kind of multiply it out. What do you get? You get I plus, this is going to be A squared, let's see, minus B squared, and then it's going to be plus 2ABI. And over here, well, I made a mistake there. I just realized I'm squaring something. I'm not squaring it. It's I. It's the other side I'm looking at. Let me get my eraser out again. I do that sometimes. I start squaring something that's not being squared. It's I plus BI. That's this. That's that plus A. This is the imaginary part. That's the real part. Over here, A squared minus B squared plus 2ABI. And I equate coefficients over here. And what would I say? I would say that the 2AB would be equal to the coefficient over there, which is 1 plus B. And I would say A is equal to A squared minus B squared. I'm equating this with that, all right? Now here's the problem, by the way. And what I did, I want to tell you where they're written down for you. They're written over here, all right? I got this one written down, got this one written down. And what I did was use a computer algebra system to solve it. And I was able to do that. I'll be honest with you, it still takes a lot of work with the computer algebra system because they don't write the numbers the way I like to see them written. But I did rewrite it, and I got two answers over here. All right. Now, granted, there's one way to check this. You square both of these things, and make sure you get what you need to get. But I'll be honest, I'm still like my head wrapped around this thing is not so easy to do. So I had to start thinking about it, and I was starting to itch a little bit about this one over here. All right. Now, granted, this is the way I initially attacked the problem. After I did that, I did watch the video, and I want to point out. I'll be honest with you, not that it's a different way, but it's a way that your calc teachers would have probably done it. I'm going to do it the way the other guy did it, which is this thing over here, and then just simply get a nice little quadratic. Let me just go through that. What are you going to get? When you square both sides, you're going to get x, because this thing is equal to x, by the way, and then it's going to be plus I is equal to x squared. And again, you certainly want to be able to square that. If you did square that, you can get I plus the nested root again, and that's just x. That's why I'm writing that down, by the way. And what do you get over here? You get x squared minus x minus I equals 0. And you can use quadratic formula for this. A equals 1, B equals minus 1, and the C equals minus I. And let's see if we can write that down now. So what's x equal to? Let's take a look. It's going to be 2 in the bottom. The opposite of B is going to be 1, plus or minus The b1 squared is 1, and then you get minus 4ac. That's going to be plus 4I. All right? And that's where the guy stopped. All right? I got to be honest with you. I don't think you should stop there, but that is an answer to it. What you should be doing is denesting the root. And denesting these roots is not going to be easy to do, by the way. So it's going to be more work. So there's more work over here. My gut feeling, though, if you do the work, you put the time and effort in, you're going to be getting these things over here. You're going to get them. All right? A lot of work, though. All right? So anyway, that wasn't too bad to do. All right? I did appreciate what he did. But again, he stopped. He stopped right here. That's where he stopped. Where did I stop? I stopped over here. All right? I always had the vexing feeling about convergence in the back of my mind, by the way. And I'm not that good with complex numbers, but I was wondering if it's convergent. So, sort of like, the internet's a nice place to ask people. And one of the YouTubers came forward, this guy over here, and he said the following: you can show that it converges by showing the function as a contraction by using the Bannon fixed point theorem. The function does evaluate to a contraction if we assume the argument of x, and by the way, this is the x over here, the argument, well, it's really going to be, there's going to be like an I involved over here, and he's saying the argument of x somewhere between 0 and pi, all right? And that's always going to be true if we assume the square root to be the principal root, all right? I also went on to ask OpenAI to do it, all right? OpenAI actually understands LaTeX input, by the way, which allows me to type in, this equation over here. And that's what I did. I typed it in. I asked it that question. And what it goes on, it responded really kind of nicely, too, by the way. And I can ask it to also tell me the LaTeX code for it. I do edit it a little bit. For the most part, it's pretty good at it. All right. So I, determine if this thing converges. That's what I asked the question. I asked. It says, set equal to x, which is the original problem, by the way. And then it's got this business over here, writes this down, does this over here, like we did before the quadratic formula, tells you what those things, just like we did, by the way. It gives this over here. And then it does something, it really doesn't add much to it, but it is sort of verbose, by the way. And they say, inside the square root, you have this over here. The magnitude of that number is root 17. The argument is the arctan of 4. And the way you would do that is just draw a picture of it. I'll go through that with you. It's 1 plus 4i. This is real, and this is imaginary. And 1 plus 4i looks like this over here. And that's going to be 1, that's 4. And the angle theta, or the argument, is the arctan of 4. That makes sense. The length of that thing is going to be 1 plus 16, which is 17. And they write this over here. But I got to be honest with you, it doesn't change it. It's really the same thing. You can multiply that, you get the same exact thing, by the way. All right? So, again, my concern about this one over here is that, in the back of my mind, before this guy responded, by the way, and again, I do thank this guy for responding, was about the convergence of that. But anyway, no one's denesting it, all right? I did denest it, though, all right? And the denesting's over here, all right? So this was where really all the work came in. For me, that was a lot of work, by the way. I did use a computer algebra system to help out with it. By the way, I'd probably use a computer algebra system to denest that as well, by the way. But it denest, and you're getting in the form, A plus BI. Now, by the way, if you notice these things over here, they're simply just the conjugates of one another, right? So maybe I shouldn't say that in total. No, maybe I shouldn't say that. But anyway, we got this one over here, got this one over here, and this is where all the work came involved. Thank you.